Circular references are very powerful, but most people don't understand them, so Microsoft developed a different method of solving these types of problems. It still requires iterating on numbers one at a time until it reaches the optimal solution, but much of the complexity is hidden from the user. This functionality is called GoalSeek. On the next few tabs, we'll explore GoalSeek and apply it to a variety of problems. Here, we want to find the indifference point, which is the interest rate at which projects 1 and 2 have the same net present value. Let's take a look here. First off, you'll notice that we have the interest rate, and then we have a series of outflows and inflows for the different projects over different periods of time. Let's say these are years. As you add those up, we can calculate the net present value for that, and in this case, it looks like it yields $240.36, or 1,000 or million dollars. And project 2 over here at 10% interest rate yields 226.03. So which project would you choose? Well, you'd choose project 1 because it earns more money. So what is the indifference point? The indifference point is basically that interest rate where these values are identical. So let's take a look at GoalSeek here. GoalSeek can be found under the Data tab, over under this Forecast and What If analysis, and there it is, GoalSeek. Now it asks for 3 different things whenever you use GoalSeek. The set cell is the cell that you want to look at to see if a value is in. So in this case, we'll look over here at our net present value 1 minus net present value 2. And when that is 0, then we've arrived. And how do we make changes? Well, we'll go ahead and substitute values into the rate up here. Let's go ahead and run that and see what we get. You saw that it kind of iterated. You could almost see it substituting in the different rates as it got closer and closer. It looks like we reached the target value there. Here, it looks like when the cost of capital is 12.26%, that's when it doesn't matter which project we choose. We saw before that at 10% you would choose project 1, so we could assume that anything less than 12.26 you'd choose project 1, anything greater you would choose project 2. GoalSeek doesn't maintain your answers, so you might want to just note what we put in for our set cell 2 value and by changing cell values there. Okay, let's go on to the next problem. Okay, sometimes the BYU bookstore has a progressive book sale. This means that the books are 10% off the first day, 20% off the second, and so on until they're 50% off on the 5th day. You would really like to buy 5 particular books, but you only have $40. Because the books might get sold out, you would like to buy them as soon as you can afford it. So we want to use GoalSeek to solve this problem. Let's check this out. So we have the interest rate here. We have the prices of the books. We have the total value, just by summing those up. We get a discount on them, and then we have to add sales tax, and then the final price. So we need this price to be $40 or less. We can't avoid the sales tax, and we want to maximize our discount rate. At least it needs to be higher than that so that the final price will be down to 40. Okay, let's take a look at GoalSeek. So what will our set cell be here? Well, that's right. It actually should be the final price down there. What value do we need it to be? $40. And what are we going to change on our worksheet? We'll change the interest rate there. We'll go ahead and say OK. And it looks like we get 39.23%. So what day would you buy those on? Well, day 4, because we need to round up. Now, on this problem, we could just put in 10% and then 20%, 30%, 40%, probably find out soon enough. But it really wasn't that difficult with GoalSeek. We just need to know which values to stick in those parameters. Okay, let's take a look at the next one. Here, Anna wants to have a good shot at being admitted to the accounting program, and for that, she must maintain a 3.5 cumulative average. We need to figure out what the GPA she should have in fall of 2008. Okay, let's take a quick look here. So we have our GPAs and the credits, and then this is the total number of credits that then will help us to take the sum of those and divide by the total number of credits to see where she ends up, and we need that to be 3.5. Okay, we'll go to GoalSeek here. And let me go ahead and have you run this. Go ahead and pause the video, and when you're done, go ahead and play again, and we'll compare answers. Did you get 3.38? Okay, I think that's the right answer. So what's our set cell here? Our set cell should be the cumulative GPA. And Anna needs to maintain a 3.5. So we'll put that in. And what are we going to change? Well, we'll change the GPA for fall of 2008. We say okay, and we get that 3.5. And so the GPA for fall of 2008 would be, she needs a 3.38. Okay, let's look at one more problem. This problem is for a car loan. Jim thinks he can afford a car payment of $500 per month. His bank has a financing plan that includes zero down and an interest rate of 12% over 24 months. What's the highest priced car he could afford with these terms? Go ahead and run GoalSeek, and let's see if you can come up with the right loan amount. Did you get $10,622? If so, I think you did it right. Let's go ahead and solve it together. Come up and run our GoalSeek. So our set cell will be the payment. What should the value be? 500? Well, it should be negative 500. Why negative? Well, it's an outflow. With a cell, the outflows are always going to be negative and the inflows are positive. In fact, we'll be covering several financial formulas. You got to get in that mentality. Outflows are negative, inflows are positive. Here, we received a loan, that was an inflow, and our payments out every month are outflows. So negative 500. And what value or cell are we going to change? We'll change the loan amount. We'll say okay. And there we get $10,622.